Hello, all the crazy people out there. My name is Michael. I like wizards and dragons and making games, and let's get around to doing at least two of those three things, possibly all three. We'll see. So this is the second week of officially the second week of my new follow along game dev series. We have got ourselves a 3D camera rendering and 3D space, and we can move it around and we can look at things, and that's as good a place to start as any. The first couple of videos in the series are probably going to be a lot of like rendering setup before we really get into interesting gameplay things, so you'll have to bear with me as I go through that. This is my list of tasks for today, so we're going to start getting more things in the game and possibly getting around to deferred rendering. I'd like to get around to deferred rendering. Deferred rendering in GameMaker is fun. I'm also going to probably start talking a little bit more about this 3D model conversion program that I've got. I messed around with it a little bit last week, but didn't really explain for anybody who isn't familiar. I guess I'll do that now. This is my 3D model manager. It is a program which you can like drag and drop 3D objects into, whether those are like old GameMaker 8 D3D files or like regular wavefront object files. And you can use them to like look at them. You can assign a texture to them. You can play around, transform them in different ways. It's also got some functionality to add like collision shapes, collision shape information to these things, which will be useful when it comes to actually doing like collision in the game. But I'm not going to go there now. And from here, you can export these as just vertex buffer files with a given vertex format. You can either export them all individually or you can export them all together. And then you can load them into your game nice and easy without having to do any gross things like parsing OBJ files, which is slow and boring, and there's a lot of additional code you have to write and nobody wants to do it. So let me go and do that. If I were to select all these and export them as like a vertex buffer collection in the data files of this wizard GameMaker project, I could save a single file which contains all these, which I can load in later. I think that I'm actually going to not include the 3D face normals for this. After all, I said that I probably would last time, but I really can't think of any reason why I'd want to do anything that wasn't calculating normals in the fragment shader, because that's just as easy, honestly. Once you have like the either the world space or view space position, whatever the case may be. And as such, to save 12 bytes per vertex, I'm going to just do that. So let's export this. I'm going to call this just a vertex buffer collection of something like... I'm going to be boring and just call it meshes. I can save this project. Do I have a workspace folder for this yet? I do not. Alright, I'll worry about that later. So right now the like initial test block that's in the game was just loaded in as just a single vertex buffer file that I can just like suck in off the hard drive and turn into a vertex buffer. That is not quite going to be that easy when it comes to the vertex buffer collections. Instead, I have a set of what I have called Penguin import scripts, and that is a GameMaker extension which I can just add to the project, and that's going to contain a couple files. To access, I can just say penguin load. I can give it the name of the file that I want to load. And I can give it the, I also need to give it a vertex format, correct? I can give it a vertex format. I did remove the vertex normals, so I'm going to need to remove the normal attribute from that vertex format, but other than that, I should just be able to leave it alone. This is going to return an object. I can just call this like self.meshes or something along those lines. And the return value of this is just going to be basically a struct containing all of these vertex buffer objects. And it's going to be a little bit more than raw vertex buffers. It's going to be each one of these models is basically its own object which contains a vertex buffer, and it contains a like any relevant collision information or anything like that. They also contain some helpful code such as render methods. And if I wanted to, for example, draw one of these blocks, I'm going to comment out the original vertex buffer loading like this. I'm going to come over here. I'm going to say, instead of vertex submit, we can say self.meshes.block dot render. And we can do that in place of all of these. There's a bare bones vertex submits. And if everything has gone according to plan, that should draw everything. And it does not. Did I spell something different? Oh, it's block singular. Block underscore singular. Okay. All right, here we go. We are now rendering the vertex buffers through this this penguin system. I love that it's called that. I did not come up with that name. I asked one of my friends to name a random bird. He gave me penguin, and that's its name. Now, you might notice that it automatically drew that with a texture. Penguin does not actually like save texture information when you import a 3D object into it. You do have the like list of textures that you can have like previewing in the window, but they're not exported when you export like a vertex buffer collection. If I were to instead say something like meshes.chest.render, because that's another one, this would not be drawn with a texture, and it would instead be drawn just like as a like. We seem to be on our sides. Oh, you know what? These are using Z up instead of Y up, aren't they? I should probably rotate them. Anyway, not important right now. This is rendering just like a white texture like what GameMaker uses when it doesn't have a texture to use. And if I were to load in a sprite with the same name as text underscore chest, which is the one that it uses in the editor, it will be able to automatically find that. Text underscore chest. It will, as is often the case, have to be on its own texture page, but we will have the treasure chest now rendering with that correct texture. So that should make things fairly easy. This kind of has some like texture repetition issues on the side, but that's a modeling problem. That's and the chest is going to be like facing downwards anyway. If I wanted to like draw all of these test objects in sequence, we have let's see, the barrel, the chest, the rock pile, and that was the one that I loaded in earlier just as an example. So let's draw the barrel. We can also draw the rock pile at another position, and if we want them to have textures, again, I'm going to need, that was the wrong folder, barrel and rocks over here. You can go on your own texture page, and you can go on your own texture page. And I will organize the asset browser more, probably not too long from now. But we now have ourselves a barrel, and we now have ourselves a rock. All right, that's as good a place as any to start. I should probably commit some of these changes, shouldn't I? Let's do this in pieces. So first, I added penguin to the project, which is going to account for this and that, and that's going to also be these files. And secondly, I added some new test objects. But first, I actually want to like make sure that they all have the correct up axis. Unfortunately, all right, that looks good. So we forward is going to be positive Z in this case. I did add a button that just says rotate up axis, and you can rotate them. You can rotate the up axis in either direction, and I think this is actually like aligned to the axes and doesn't really need to be rotated. That just changed the direction of the textures. We can also rotate that one, and that's going to be the these are the correct up axes. I can also draw the ground. I suppose if you want a ground, and I'm going to just say meshes.ground.render, and I'm going to want this this grass tile here. Okay? So this is going to... Excuse you? I totally rotated these objects according to the wrong axis, didn't I? I was using like X up instead of a Y up. Congratulations, me. Anyway, this is going to be our test scene. I am going to commit these changes to GitHub finally. Those are going to be my test objects. Let's see. I can say I've added these. I can say I've added the test vertex buffers. The deferred rendering geometry buffers, I guess I'll do next. This is obviously going to not be what my final like draw event looks like in this game. Stuff will get rearranged eventually. Let me create myself a shader. Where's shader? Shader. This can be shd underscore. I'll call it gbuff. Let's call it main. There's probably going to be a few different shaders for things in this game world. Not everything will have the same geometry buffer shader. Let me get rid of the junk in this that I don't need, this default shader. We only need position, color, and texture coordinate. We can say the object space position is a bit of a simpler expression. Writing it out that way is a tiny bit inefficient. GL underscore position is the result of this. That's fine. I'm going to want, I believe, a few other varyings to be calculated. One is going to be varying vec3 v underscore v for vector3 world space position. No, it's going to need to be view space. I want to do everything in view space because this is a deferred thing. I want a varying vec3 v underscore v vs normal and a varying... In my my earlier tutorial on deferred rendering, I also had view space depth, but I can derive that from view space position, can't I? Anyway, so the color, the texture coordinate, that's fine. That can stay. V underscore v vs, that's a lot of v's. Position is going to be equal to gm underscore matrices. Matrix world view. That's going to be multiplied by object. There's no code help in the shader editor. No like auto completion or anything like that. That's going to need to be xyz. V underscore v vs normal is going to equal this, but we're going to say... Oh, you know what? I got carried away because we're not going to be doing normals in the shader either. In the, like, as a vertex attribute. We don't need to transform a normal. That's fine. Okay, we can derive that from the view space position as well. Alright, let's see. I'm going to need to take this varying over to the fragment shader. And GL frag color should be GL underscore frag data. Index 0 is going to be the result of this. That's going to be the diffuse color. I'm also going to need to set up the GL underscore frag data index 1. I'm going to make that the view space normal. Let me just say that's going to be a vec4 containing some values. And there's also going to be GL underscore frag data index 2, which is going to be also a vec4 containing some values. So first I need to calculate the view space position. And this is going to be, let's see, a vec3. I'm going to call this get vs normal rather, not vs position. If that takes a, I should probably give that a parameter, right? So that's going to be vec3 vs position. I'm also going to want a vec3. I'm going to call get normal as color. That's going to be a vec3, which takes a normal. I'm also going to want a vec3 get depth as color. That can be just a float. And I'll fill in each of these eventually. I've made videos on all these things in the past, so this shouldn't be like too overly scary right now. I do, however, need to look up how to actually do this. I know that I always have to look up which values exactly I have to cross against each other, so it's kind of a good thing that 57 shader normals is that it's kind of a good thing that I have this like massive amount of like GameMaker 3D documentation that I've created, because I don't memorize things. I just know ways to access the information quickly. So we no longer have to do this. Unless something's changed in like GameMaker 2023.1, which I'm using right now, we no longer have to enable shader derivatives manually. They are enabled by default. Where are we looking? I need to dfdx the world position, or I guess in my case the vspace position, dfdy the world space position, and then cross those two values against each other and normalize it. Okay. I can say vec3 ddx is going to be dfd. Is it a capital F? It's capital F, isn't it? Fine, I'll copy and paste. Wanted to do this without copying and pasting, but when OpenGL shader language just capitalizes random letters in the middle of function names, that pushes my patience just a little bit. This can be vec3 vs normal is going to be the result of the cross product of the dx and dy. That's going to have to be normalized so that it's got a unit length of 1, and then we can simply return vs normal, or we can just like return this value to begin with. And that's going to be our view space normal. And to convert that to a color, this isn't that bad. This is going to be return. We're going to change its range from -1 to +1 on all 3 channels to to 0 to +1 on all 3 channels. So this can be norm times 0.5 plus 0.5, and that's going to shift the range. You can also do that with a matrix transform, but why would you? Do I want to do this all at once and then like test it all at once later, or do I want to like test it in pieces? I'll do it all at once and test it later.
Hey.
Let's see. What do I have? Const float depth scale factor. It's going to be a vector3 mod. You know what? I can copy and paste this too. Again, I've done videos on all this in the past. This should not be anything like new. The only point of conflict here is that in some of these, in the original version, I was using like camel case, and today I'm using snake case. All right, take that, camel case. Camel case is not my favorite code style. I don't know why I used it in the original videos, but that doesn't matter. I'm probably also going to want vec3 get vs depth, vec3 vs position. This is really just a formality. This is not the most like efficient way to get this value. The shader compiler should honestly be smart enough to optimize this into like an inline function call. But just so that, the reason I'm doing this, even though it's a little bit maybe not ideal, is so that get vs normal and get vs depth and get normal as color and get depth as color all look the same in code. Alright, so what I'm going to want to do is get normal as color. This is going to be a function which is going to take, what was it, get vs normal as a parameter, and the position that's going in there is going to be v_vs position. This is a vector3. Its alpha value is going to be 1. There's going to be something similar happening with glfrag data index 2. That's going to be get depth as color, get vs depth, v_v vs position. That's also going to take an alpha value of 1, and that should be all 3 of the things we need for the geometry buffer. All right. So now when we draw the world, we can say shader set shd gbuff main. We need to set a single uniform shader. Set uniform float shader get uniform. The name is going to be camera zfar, and the value that we can use as that is literally going to be self.camera.zfar. And at minimum now, we should have some syntax errors. Some oh, this needs to be a float. Yeah, that needs to be a float. Compiler errors, not syntax errors. So we have the world rendering as before. We do not have any render targets set to our secondary geometry buffers. We can do that. I'm gonna say self.gbuff normal is gonna be a surface create. I'm gonna manually set this to window get width, window get height. And I'm also going to have self.gbuff depth. And in the draw event, in addition to setting the shader and the shader uniforms, we can say, what is it? God, I can't remember the function name. Really sleeping on the job today. Surface set target extended. Surface set target extended. The index is going to be 1, because we are first going to set the normal normal render target, and that's going to be self.gbuff normal, like this. And secondly, we're going to set 1 to 2 self.gbuff depth. And let's see, we don't have to unset those at the end, which is nice. Let's go to the for now the draw GUI event, and I'll probably make the next video about like tightening this up a little bit. Draw surface extended, self.gbuff normal. We can draw this at position, let's say 0, 0. The x scale can be 0.25, y scale can be 0.25. Rotation 0, color c underscore white, alpha 1. And we can also draw the depth. We'll put this at, let's say 400. Actually, that'll be yeah, that'll be on the side. That's fine. All right, so we can now draw both of the supplemental targets there. We need to do some screen clearing when we do that, because we've got some Windows 95 happening. But other than that, I say it looks approximately correct. So these are the view space normals when I'm looking at something head on. It should be a little bit, what would that be, like 50% orange? Because that would be like 0.5, 0.5 as a color value. When it's looking up, it's obviously greenish. Other angles, they work. And we also have our depth on the side. So that's, I'd say, working correctly. I'm going to draw that at 256 on the Y, just so that it's not quite as far away. All right. How long have I been recording for? So this recording is going on 35 minutes. There's going to be a little bit of me staring blankly at the screen. In the middle of when I couldn't figure out, for example, why we were drawing things aligned to the x-axis instead of the z-axis. Do I want to do a combined, do I want to implement a combined geometry buffer now? I said I would. I guess I'll do it. I don't like these videos going on this long, especially not the early ones, but let's see. I'm going to create myself a an Uber shader. Call this SHD underscore deferred. And this is going to take three samplers and combine them into one. I do not need the color varying because there's really no point in Positino. There's really no point in blending the deferred rendering surfaces with any color. I'm going to once again have to look at my test project so that I can see. Oh, there's going to be a lot of this, isn't there? All right, would people be mad if I said I've already done like a bunch of videos on how to do this, so if you want just a tutorial, like, go watch those? I kind of feel like I should do that. Just in the name of time. All right. So this is going to be copied out of 3D Tutorial 60 Deferred Rendering. Not all of this is going to be used. For example, I don't need these like lighting varyings right now because I'm going to be getting to lighting later. But the normal sampler, the depth sampler, the camera's Z-far, so that we can figure out like exactly what how to like unpack these values we're going to want. Other than that, I'm going to get rid of the lighting and fog calculations for now. I'll get to lighting and fog later. I don't know if I'm going to do that in the next video or if I'm going to do something else in the next video. Fragment normal, fragment depth, fragment position. From here, I should just be able to let's go into, instead of draw GUI, let's just move to post draw now and call it a day. This was going to be the post draw event eventually. I guess I can leave those on the screen, it won't hurt. Shader set, SHD deferred, shader set uniform float, shader get uniform. The name is going to be something I don't remember. The value is going to be self.camera.zfar. Let's see, what was the name of the uniform that I want? It's going to be this in the field of view scale, isn't it? And the field of view scale is going to be a vec2, I believe. And the exact value of that is going to be, it's going to be something like the, all right. This needs to be the tangent of self.camera. FOV divided by self.camera aspect divided by 2, or times the aspect ratio rather. That's going to be the value on the x. The value on the y is going to be the tangent of the camera's field of view divided by 2, because we're looking for half the field of view on half the screen on each axis. And I may need to negate some of these signs like that. This will probably become more apparent once I actually get to lighting, but let's see. Next, we're going to say texture set stage. The sampler ID is going to be shader get sampler index SHD deferred. I think it's like what, samp norm. That name I sort of remember because I've written it out enough times. The texture is going to be surface get texture. Gbuff normal. That is the correct number of parentheses. Samp depth can be gbuff depth, and I think, oh, obviously I'm going to want to say draw surface. That needs to be the application surface at 0, 0. And we're not doing any fancy lighting calculations now, but we should have the diffuse color coming through. And if you wanted to mess around with it, you could like mix that with the call underscore normal to make sure that it was like sampling the correct value. Mix it by a factor of half so that we see like half the diffuse color, half the normal color. No, are we not doing that? Oh, you know what I need to do also is application surface draw enable false. Set that to false, and that way we won't automatically draw things later. So now we have, it looks like you are being like drawn blended with white, which makes me think that one or more of the surfaces is not like getting bound correctly. See, this is where game dev gets like really fun. I don't think I'm spelling these wrong, am I? Oh, it is samp normal, not samp norm. See, this is why I copy and paste so that I don't have the opportunity to make dumb mistakes like that. All right, now we have realized each of the render targets that we want. Okay, so I think I'm going to leave that here for today. I am going to try and record a couple videos ahead. I'm not going to go wild the way I do with Let's Plays, but let me know what you think of like how this project is being structured so far. This is what I do when I create a new project, generally. Like, it varies depending on what kind of game I'm making, but if I'm doing anything 3D, this is usually how it looks in the first hour or so of the project. And if there's any, like, confusion about, like, why I did things in a certain order. And I don't mean about like if there's any confusion about the math, because like I said, I've made many videos on the math in the past. So if you want to know about deferred rendering, I would recommend those. But like why I'm setting things up the way I am, I think are the more interesting questions right now. So if you've got any of those, I'll answer them whenever I get around to answering them. I've been recording for 45 minutes, which is, again, longer than I wanted to do this early in the series, but I did say that I would be getting the deferred rendering in, or at least setting up the deferred rendering. We're not doing lights yet, so I guess I'll leave it there. Let's see, I can close that. I can complete these cards, and I guess I'll have a look at the milestones. Actually, there's not that much interesting in that view besides the calendar. This is where the metrics are. And we can see what our trajectory is. Still not enough data. I don't know if this is only because I'm doing this like once a week on average, or at least we'll be doing this once a week on average. But the like trajectory, like metrics down here at the bottom, don't seem that informative right now. Maybe after like a month there'll be more days in the project where things got done. But yeah, I don't expect this this graph to be all that meaningful anyway, because there will be days in which I record like 2 or 3 videos, and then there will be days in which I record none. Anyway, that's where the project is. As for the tasks at hand for tomorrow themselves, I'm probably going to, let's see, there's some like busy work that won't take long. It won't necessarily look a lot like a game. I guess I can do like skyboxes tomorrow. I can, for example, just add the 3D particle system. I can do that. I might not. A billboard shader. This is going to be used for something I mentioned, not what most of you are probably thinking of. If you've gone deep into the technical design of the Unreal Engine 1 Paga games, you may know what's coming. But other than that, I'll explain later. There is a water shader. I'm not entirely sure if I like want to have water in this game. I don't know if I want to deal with having to contend with a player getting in water and swimming in or whatever. These may or may not end up getting like merged into the same thing. I'll do them tomorrow, next time as well. Implementing fake shadows. That's probably going to be something that's more... I might move that to basic gameplay. That's probably going to be something that's more like useful to think about when we actually have something resembling a player. What the hell. I'll get S part in there for 3D particles next time also. Or at least, like, if there's time, I'll do it at the end anyway. So, that's where we are now. This is 3D Wizard Game Week 2. If you are interested in the code for this, look for the GitHub repository down in the video description. Week 0.2 is going to be the progress as of this week. If you want to see the project board itself, there will be a link to that down in the video description where you can see an overview of how this is going. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places as well. Otherwise, I hope you all find this interesting, and I will see you all later. Special thanks to Army Armbuster, DJ Gibbles, Edward Holt, GameMaker, Gamer Player, Harold Guidry, Manta Ray, Sindra Larson, Squarecrow, Vitro V, and Zengiment for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.